There has been a short but meaningful journey from the first stages of what a game is to now coding one. I have attempted to explain the most fundamental parts of reality using logic and basic principles. Now that the process has moved up to the point that it is ready to be code, though, we encounter an interesting problem. I have not made a programming language. No matter which language we choose, we are going to be using something very complex. It will likely be fully understood by very few people. In other words, it can still be effective with partial understanding, and our skill will grow from there. However, I have no real authority in any language. I'm still a fairly novice programmer at this point. A long time ago, I hoped and strived to find a single source that could teach me everything I wanted to know. The closest I came was to look into reality itself, and I have shared with you some of my findings. Ultimately, I realized that I could not expect to get all teachings from a single source. Neither can you. At this point, I encourage you to take some time and gather some resources for the language you intend to code in. I'm starting in C++ if you wish to follow along, and I'll try to dive into a few other languages soon. What resources should you choose? Perhaps look for what other people say is the best. Use their reviews as a tool for your initial discovery. Languages were crafted by people. Look those people up and see if they wrote a book about the language. Don't settle on just one book or one website. There is a lot of technical knowledge in programming, and although everyone covers certain topics, everyone also covers a topic or two that are less common. The way certain authors present the knowledge is another unique aspect, and several perspectives will be a benefit. Ultimately, I am trying to guide you through some of the essential knowledge that you need to make games. I can touch on pieces of technical knowledge, but that entire aspect of game making will be something you learn from 100 different sources. You will also learn many things through self-discovery. You will find solutions, and you will find the right questions to ask through the process of making games for yourself. Let's begin. Here I'm using the book A Tour of C++, 2nd edition by Bjørn Strustrup. It is the resource that I have. I tried a few other ones, a few websites, but nothing really worked as well as this book did. It's a short book that just has it's like just a brief about every single different possible, I don't know how much of the language it has, but, a little bit of each. So I can't really share the book directly, so I'm writing out some quotes about it and the headers that I find it under. And each of these kind of accompany the actual syntax a bit about what we need to do. But it fits in pretty directly, like every name and expression has a type that determines the operations that can be performed on it. So we find that the hold information and the multiple types info all in the same spot. A lot of these I'm finding right in the same spot, of course. That is a little bit by luck with how the book was organized. But because we were expecting to find all of these things all together as basics, it makes sense that they are kind of in big chunks. Jumps around a little bit, especially for the output and input. Those are more complicated, but for the most part, everything is right there in the books. For the CIN, that was something I had to remember. It was a little bit harder to find in the book. But we have all of our different things that we expected to find now, and now it's just a matter of completely translating our pseudocode into regular code. Here, I'm also using resources from c++.com. You'll be able to find a lot of code online and a lot of resources for the syntax of code online, along with handy little expressions like that rand modulo 100 plus 1. That is well understood what it does. And in game making, you're going to have to use a lot of mathematical formulas that have already been figured out, and you can mostly just use them like they're a completed component. So, using the syntax, I'm pretty much just going line by line in our pseudocode and translating it into C++. A lot of these are very straightforward, of course. You have to know some of the syntax of C++ and the why you're using it that way, which I'm not going to go over in this video. I'm just translating each line. This is more of like, you should be able to expect to find these things. The resources should be out there. You should be able to find them. That's the idea. There is a lot of extra knowledge that you can gain. There are plenty of resources to gain this extra knowledge, but you definitely do need it to be able to efficiently program in a language. And although this game is very basic, it's very simple, and we are able to translate pretty much directly from the pseudocode into regular code, it is going to be a lot more difficult for a larger complex game. This takes up literally just one page, not even that much, and a lot of that is just the includes and the using and the main function, which are just mostly boilerplate, mostly the same for every single program. It's not the actual program itself. It'll be more complicated with more complex programs. Now, we have written all of the C++ code for this. I just have to turn it into a program, which I'm going to do behind the scenes. A little bit of magic for that, but it's not very interesting to, it's much more just, it varies from programming language to programming language and environment to environment. But we used every single different thing that we expected. It's all in here. So we were at least accurate on that part. And we can use all of these tools in further programs to make things much more complicated. The thing is that it'll just be a little bit more tricky to write the pseudocode and then to turn it into code. And here we have our program. We have a generated number of 42, and we can enter a number. Here I enter the number 50, and it tells us what number we entered, so we know we entered it, and it tells us that the numbers aren't equal. That's what we expected it to do. And then it loops into the next part. The generated number is 68, so the loop is working correctly as well. And it's reprompting us for a number, so everything's working well. Let's enter the same number, 68. It tells us that. It tells us that they're equal, so that's working as well. And then it continues. And that's just how the program goes. It'll continue on forever. We didn't add a mechanism to leave, but we can just exit out of the program, and we can continue to enter numbers that are equal or not equal. It's a simple game, absolutely, but it is a game. And as I said, the things that we found, the constructs of the code, the constructs of the patterns in the code, and all we have to do is match the syntax of any given language for it. We can take those ideas and program anything, along with new ideas that we'll find along the way. So let's find them. Let's go.